Okay, now we proceed. Now watch and listen carefully. Number one is that this draws no current. The amplifier input or scalar input or adder input doesn't draw any current. Therefore, we can treat this as if not connected, just like if you recollect the Arduino lectures, when we derive op-amp formula, op-amp input draws no current, so you can disconnect. So if that is done, then you can say that this is this old circuit as earlier, so for which you already know the differential equation, and that remains unchanged. That remains unchanged. Whereas if we have a circuit like this, then this is VNT, this is VOT, this is VAT, this is 1, 1, 1, 1. So between V and VO you get all the relation, but between V and VA that doesn't apply, because this current is same as this current, but this current is not same as this current because something branches here. So here this branch draws no current. Therefore, old equation, so in this case which was not applicable, becomes applicable here. Becomes applicable here. What is that equation? dVOT by d. So when this was V integrated, they already declared the equation. So this is 1 ohm. Oh, I think I forgot to write. So most of you must have not completed the equation because the values are not written. Is it right? So dVOT by dt plus VOT is equal to VAT. Is it right? dVOT by dt plus VOT is equal to VAT. Is it clear? Or anybody is having any doubt on this? In this circuit, VAT is coming as output of the adder. What that is, we will write later. So if we treat the output of the adder as input to my RC circuit, the old equation holds good, because even though the output of my RC circuit is taken back, it draws no current. Therefore this holds good. Now, what is the relationship between VA and VI? So I have another equation. VAT is equal to this plus this. What is this? Scalar. So there is no need to write V2T, then V2T equal to A into VOT. It is very simple now. So VAT is equal to this input plus this input. This input is VNT and this input is this into A. So it is VAT is equal to VNT plus AVOT. Is it right? AVOT. So this is the equation which we have. We ultimately want differential equation in terms of what? VNT, VOT, the differentials. So in that equation, what is unwanted term? VA, right? So replace it. Only we have VAT is equal to VNT plus this A will be there because it is part of the circuit, right? So dVOT by dt plus VOT is equal to VNT plus AVOT, right? Is it okay? This is the final equation. Only thing is that we have to rearrange the term. VOT is on both sides, so we have to rearrange, right? So dVOT by dt plus A comes on the other side, right? So 1 minus A is it right? dVOT by dt plus 1 minus A into VOT is equal to VNT. So I am sure that most of you, many of you might have written this equation, right? This or no, I think many might not have thought this. So this might not have been written. So this is the answer. In the answer, we need to check, is there any unwanted term? No. It is differential of output. Output as it is, input as it is. And 1 minus A, which is the circuit parameter. Is it okay? Right? So if A is 0, what will happen? If A is 0, it is as good as not there. So this not there means this is as good as this. So original equation. If A is 0, it is original equation. dVot by dt plus Vot is equal to V in t. If A is 1, dVot by dt is equal to V in t. If A is 2, dVot by dt minus V in t is equal to, so minus Vot is equal to V in t. So a single constant A leads to multiple coefficients and multiple differential equations where we may get many answers. Is it okay? Now next very important circuit we will discuss, that is by using buffer and without using buffer. Is it fine? So first circuit, I think we have derived this, but when I show like this, there is no need to draw I hope that now you are seasoned enough that no need to draw the ground line as such. When we ground, it is enough, and when we write, when nothing is mentioned with respect to this common ground. For this have we derived? For this equation, for this circuit, have we derived differential equation in the class? Have we derived means, have I derived, have you seen?
Yes.
What is that equation? Equal to 1. So he recollected it. So for those who could not recollect, can again think it and derive after the lecture. So now we will make a small addition there. So here what we have done, output of the first circuit was taken and it was connected to same circuit as an input directly. Now I will make a small change. The small change is like this. Same circuit I will take and I will add derive the differential equation for this given circuit in terms of VT and VT. Derive the differential equation in terms of VT and VT. So again let us take a pause, means not let us take, we don't take pause, we pause the video, you solve the equation and then we again start.